Welcome to Get Your FRQ On. This question is from 2023. It is question 4, and it is not calculator active. In the question stem, we have a function f, and the only thing we know about f is that f of 2 is 1, and f prime of x is given in a graph, which consists of 2 line segments and a semicircle. In part A of the question, we are asked to determine if f has a relative minimum, relative maximum, or neither at x equals 6. So in order for f to have a relative extrema at x equals 6, f prime of x would have to equal 0 and also change sign at x equals 6. Now, depending on how it changes sign, does it go positive to negative or negative to positive, that will determine whether or not it's going to be a relative minimum or relative maximum, but both conditions have to be satisfied. So if you check the graph for f prime of x, you can in fact verify that f prime of 6 is 0. However, it does not change sign at x equals 6. It's positive to the left of 6 and positive to the right of 6. So even though f prime of 6 is equal to 0, there is no change in sign, so f has neither a relative maximum nor a relative minimum at x equals 6. In part B of the question, we are asked to determine intervals where f of x is concave down. Normally, if we had a function f, we would just find its second derivative, maybe write an inequality or two to determine when it's going to be negative. We don't have the advantage of doing that here. All we have is a graph of the derivative of f. And as always the case, whenever you justify a conclusion in a free response question, you want to make sure that you tie your conclusion to the given information. Since the only thing we know about f is f prime of x, we have to be able to tie our conclusions about concavity of f to something specific about the graph of f prime of x. Now you may know this, but f will be concave down when its second derivative is negative, which means that the first derivative is decreasing. So if we check the graph of f prime of x for intervals where f prime of x is decreasing, that will correspond to intervals where f of x is concave down. All right, so check the graph of f prime of x, and you can tell that f prime of x is decreasing on negative 2 to 0 and 4 to 6. From this, we can conclude that f of x will be concave down on those same intervals, negative 2 to 0 and 4 to 6. In part C, we are asked to find the limit as x approaches 2 of the expression 6f of x minus 3x over x squared minus 5x plus 6, if it exists. Now, in order to do this, this might be a L'Hopital's rules question, it might not be, but in order to find this limit, we should probably verify that the limit as x approaches 2 of f of x actually does exist. And the way to do that is, it's kind of difficult to do because we're not really given that. We're given that f of 2 is equal to 1. However, we can tell from the graph of f prime that f prime of 2 does exist, which means that f is continuous at x equals 2. Remember, differentiability implies continuity. And the definition of continuity would imply that the limit as x approaches 2 of f of x is going to be f of 2, which in this case happens to be 1. So we should actually verify that that's going to work. Now, if you do the calculations mentally, you can see that this is going to be an application of L'Hopital's rule. It does end up being 0 over 0, which is indeterminate. I like to show these limits separately. There's often questions on, when can you write 0 over 0 or infinity over infinity, and when will you not earn points for that? I just do it separately. So the limit as x approaches 2 of 6f of x minus 3x is equal to 6 times 1 minus 3 times 2, which is 0. And the limit as x approaches 2 of x squared minus 5x plus 6 is 4 minus 10 plus 6, which is also equal to 0. And so I could just state that the limit in question here, the limit as x approaches 2 of 6f of x minus 3x over x squared minus 5x plus 6 is indeterminate. I don't have to use any wonky notation or anything like that, clearly communicating that this would not be a limit that you can just find regularly. You would have to use L'Hopital's rule. All right, so if we know we have to use L'Hopital's rule, let's use L'Hopital's rule. If I take the derivative, the limit as x approaches 2 of 6f prime of x minus 3 over 2x minus 5 at x equals 2, if I plug those values in for x, the derivative at x equals 2 of f is 0. So my numerator is just negative 3, and if I plug in 2 for x in the denominator, I get negative 1, so that becomes positive 3, which implies that the limit as x approaches 2 of the original expression, 6f of x minus 3 of x, all over x squared minus 5x plus 6, is also 3. Now remember, when you do a question like this, if it requires L'Hopital's rule, you do need to verify that it is indeterminate. You do need to find the limit of the expression that uses the quotient of the derivatives, and then you also need to explicitly state that this is equal to the limit of the original expression. Don't forget, you are asked to find the limit of that expression, 6f of x minus 3 of x over x squared minus 5x plus 6. So your answer had better explicitly state that you have found that limit and that it is, in this case, 3.